Hello, my name is Daniil Nagy, and this fall I'm teaching a seminar called Data Mining the City. In this iteration of the class, we will be focusing on artificial intelligence and machine learning, and how this technology can impact the fields of urban planning, architecture, and design. The idea of an artificial intelligence fascinated technology thinkers and futurists even before our current era of computing had taken hold. Half a decade ago, early computer scientists came up with the idea of creating computer systems that could mimic the organization and functions of our own brains. The human brain consists of a huge network of interlinked cells called neurons, which can communicate and pass information to each other through electrical impulses. By continuously growing, adapting, and rearranging itself throughout our lifetime, this network is able to learn patterns from our experiences and allows us to predict what will happen in the future based on what has happened in the past. Computer scientists working in the 1960s thought that by mimicking such a dense network of simple units in software, we can one day create a computer with an artificial brain that functions much like our own brain, thus giving the machine a form of intelligence similar to our own. Although such artificial neural networks were first theorized more than 50 years ago, it is only in the last decade or so that computer systems have become powerful enough to actually put these ideas into practice. In the last few years, even personal devices like smartphones and laptop computers have reached a level sufficient to put these tools in the hands of average computer users. This rapid technological development has led to an explosion in the field of machine learning in recent years, going from relative obscurity at the turn of the century to a constant presence in our lives today. This has been largely due to their quite unexpected and uncanny ability to solve many of the most challenging problems in computer perception and artificial intelligence. In the last 10 years, the tools of machine learning have revolutionized many industries, including scientific research, banking, insurance, and medicine. Whether we realize it or not, they have also had a deep and profound impact on our everyday interaction with technology and with each other. Everything from online search to social media to new developments in digital assistants such as Apple's Siri or Microsoft's Cortana have been made possible by this technology. These are the algorithms that tell us what we want to buy on Amazon, what we want to watch on Netflix, and who we want to be friends with on Facebook. So while each of us interacts with machine learning algorithms on a daily basis, most of us have no idea how this technology actually works or whether it can be useful to our own practice as designers and urbanists. While the low-level implementation of these algorithms requires a knowledge of advanced mathematics and computer programming, the core concepts are actually pretty simple and intuitive, and there are now many tools available that allow even non-technical users to access the potentials of this technology. In recent years, there has also been an emergence of many uses of machine learning beyond the technical and scientific. Within the last year, we have seen several interesting and groundbreaking applications of machine learning in art and design. I believe this is just the beginning, and we are witnessing the very nascent early stages of how this technology can be applied to artistic and design practice. This seminar will introduce you to these concepts and explore how they can be useful for our practices in urban planning, architecture, and design. The class itself is divided into two sessions. Session A is devoted to an accelerated crash course in the tools and technologies of machine learning. Students will be expected to attend all lectures, which will introduce them to the core concepts of this technology. They will also complete a series of weekly technical labs that will implement basic applications of machine learning algorithms for solving traditional problems in artificial intelligence. Session B is devoted to targeted discussions and workshops focusing on how these technologies can be applied specifically to urban planning, architecture, and design. During Session B, students will work either individually or in groups to develop a research project that applies machine learning to a given problem in their field. Data Mining the City welcomes students from all departments within GSAP. All work will be done within the Python programming language. Although prior experience with coding and programming will be useful, it is not a prerequisite for taking the course. The material in Session A will cover all the technical skills you need to know, but be prepared that this can be a very challenging course, especially if you have never worked with code before. Session A can be taken on its own as an introduction to machine learning, but participation in Session A is required for taking Session B. Thanks for your attention, and I'll look forward to seeing you in class.